Hey there guys, we're going to go through and we're going to learn today about angle bisectors. So first thing we will start off with is the definition of an angle bisector. So an angle bisector is a line or a ray that splits an angle into two equal angles. So we have our picture here. We have our original angle CAB, okay, angle CAB, and we can see that line and it's cutting it into two angles. And the two smaller angles, I'm going to put a point right here, point D. All right, the two smaller angles are going to be angle CAD and then over here angle BAD. And the key thing is, just like with segment bisectors, since it is bisecting it, we know that these two smaller angles are equal. That is the key thing. And if we add the two smaller ones together, we get the bigger one. So we will do our first example. It says ray AC bisects angle DAB. If the measure of angle DAC is 58 degrees, what is the measure of angle DAB? Okay, so it's bisecting. We also know that these two, so we know the two angles here are congruent. Also, you can use these markings. Okay, this arc matches the same number of arcs over here. So they both have one arc drawn on them, so that means that they are congruent. So if this one's 58, the other one is 58. And if we want to know the measure of angle DAB, well, we have to take the two pieces and add them together. So we would do 58 plus 58, and that's equal to the measure of angle DAB, and 58 plus 58 is 116 degrees. Now you could also see that if it's being bisected, well, I just take the half that I know and multiply it by 2, and that will also give me the same thing. All right, next example here. It says QS bisects angle PQR. So PQR is the big angle, and it's being cut into two smaller angles. So we have PQS and SQR. Okay, so they said PQR is 6x. So this guy, the big one, is 6x, the outside. And it says SQR is 2x plus 40. So SQR is 2x plus 40. All right, now we have to use the fact that we know that it's being bisected. Okay, SQR is congruent to angle PQS. So if SQR is 2x plus 40, guess what? PQS is also 2x plus 40. So what I'm going to do, I see that there's I wrote 2x plus 40. I wrote that twice. So I'm going to do 2 times 2x plus 40 is equal to 6x. Okay, is equal to 6x. So now I will go through and I will solve this. All right, I'll multiply in here. So 4x plus 80 is equal to 6x. All right, so I multiply the 2 to the 2x and also to the 40. Now I will take away 4x from both sides. So I get 80 is equal to 2x divided by 2. So x is 40. Okay, x is 40. And then now to find angle PQR, so angle PQR, it's 6x, so I do 6 times 40, which would give me 240. And that's angle PQR. Okay, now I'm going to erase these really quick because we're going to use the same drawing for our next example. So if I were you at home, I would draw the picture again, okay? Draw draw the picture again, and then we're going to relabel. All right, it says PQS is 2x plus 21. And then it tells us RQS, so RQS is the other small angle, it's 4x minus 33. And we have to find x and then also PQR. So first thing, since I know that the angle is being bisected, I know that these two pieces, PQS, is congruent to RQS. Okay, so I can set them equal to each other. So I'm going to set the 2x, and we're done with our picture. 2x plus 21 is equal to 4x minus 33. Okay, now we'll solve this for x, so we can find our x. Take away 2x from both sides. So 21 equals 2x minus 33. Add 33 to both sides. So I get over here, 54 is equal to 2x, and then we have to divide by 2. So x is 27. All right, so x is 27 for this one. And now the key thing, you have to remember what angle we're trying to find. It says find angle PQR. Okay, guys, PQR is the big angle. So angle PQR is going to be equal to angle PQS plus angle RQS. But again, we know that the two parts are equal. So really what I'm going to do is I'm going to take twice the size of PQS. Or I could do 2 times RQS. It doesn't matter. Okay? This is also equal to angle PQR. So I'm going to do 2 times, and then PQS is 2x plus 21. So 2, and then instead of x, I'm going to put 27 plus 21. All right, and that's PQR. And so just type this in the calculator. All right, so 2 times 27, that's 54, plus 21, that's 75. Okay, and then multiply that by 2, and you will get 150. So PQR for the second problem is 150. All right, very good. Next example here, these are our last two. It says QS bisects angle PQR. So again, this line is cutting the angle in half, so the two pieces are equal. PQR, that's the big one, is 3x minus 12, and PQS is 30. Okay, since I know that QS is bisecting, I also know the other side over here is 30 as well. So what you need to do is do 2 times 30, which is going to be equal to 3x minus 12. 2 times 30 is 60. That's equal to 3x minus 12. Add 12. Add 12. So 72 is equal to 3x. Divide by 3. So 72 divided by 3 is 24. So x is 24. Now they ask us to find the measure of angle SQR. Well, we just read it from the diagram. Angle SQR is 30. All right, last one. I'm going to erase the drawing here. Again, just redraw the figure on your paper. All right, it says angle PQS is 2x plus 10. So PQS, 2x plus 10. And then RQS is 5x minus 17. So 5x minus 17. And we need to find x in the measure of angle SQR. So again, since I know that QS is bisecting, I know these two pieces are equal. So 2x plus 10 is going to be equal to 5x minus 17. All right, and how do I know that? Let me write it down for you guys. I know that angle PQS is equal to or congruent to angle RQS. So that 2x plus 10 equals 5x minus 17. All right, now we solve for x. Minus 2x from both sides. So I get 10 is equal to 3x minus 17. Go up here. 10 equals 3x minus 17. Okay, add 17 to both sides. 27 equals 3x, so divide by 3. So x would be equal to 9. All right, so x is 9. And then now we're going to do the last part. We need to find the measure of angle SQR. But remember, angle SQR is really angle RQS, okay? So we're going to plug in. So we're going to do 5 times 9 minus 17. So angle SQR, well, what is 9 times 5? It's 45 minus 17, and you get 28. So it's 28 degrees. All right, guys, so that's all there is to it for angle bisectors. I will see you in the next one.